So this is our first Build Stuff Odessa. The theme is a little bit different. We also do the Build Stuff in Lithuania and in Kiev, but they're slightly colder. And to be fair, this is the only conference that you will go to, and you will get a pair of flip-flops. For those who haven't actually looked in your bag, there are a pair of flip-flops. They look like these. Well, there's some other fun stuff going on here. If you go outside, just in that main area there, you can actually get a Build Stuff tattoo. Luckily, it'll go away within a week. It's just like a henna tattoo. It's not a real tattoo. If you really want a Build Stuff tattoo, let us know and we can probably sort that out for you. So this morning, things will be having more talks today. As we move into this afternoon, there will be more workshops, and there will be workshops as well tomorrow. As an example, I'll be doing one on Private Eye. There's one on Java 8 and how to use lambdas. I think that's actually 4 hours long. It's a very long workshop. But overall, we're really hoping that everyone just has a nice laid-back time. So getting into our first talk. Oh, I forgot to mention, there's a party tonight. It won't be very hard to find. It's here. So getting into the first talk. Over-engineering. That's what you guys aim for, right? It's to over-engineer everything. How many of you have felt like you were building something that was over-engineered? Here we have a bicycle. Now, that's a good bicycle. If you go through and you build a space shuttle, that's a very bad bicycle. And I see this time and time again when I go out to teams. They are not building what the business needs. And they get stuck in analysis paralysis. How many of you have spent more than 1 month doing analysis on a project? Just raise your hands. You are probably over-engineering. And there's lots of tricks we can do to not over-engineer. Now, if I remember correctly, here in Ukraine, it's called a dasha. In Lithuania, we call it sodas. And we have one of these in our summer garden. Now, the problem is, if we were to give this to developers, in particular developers who like to call themselves craftsmen, what we probably would have ended up with is this. We need to understand that our software, it's used to fill a job. And we're going to talk a lot about this morning, but overall, our software, it does not live in isolation. It's part of an overall business process. And I really blame our education on this one. Our education has taught us that we need to solve every problem in software. That's not true. Your software is part of a larger overall business process. And very often, the best way to solve problems in software is to not solve them. I know that sounds totally crazy. But very often, your best solution is to not solve a problem. Now, I'm curious. How many people in this room have built a framework? Raise your hand. Okay, that's about 40 hands too many. Now, I'm just curious, for the people that have built a framework, how many of you have built a framework that was used on approximately one project? It's like we have the business come to us, and they want something, and we go, well, your business problem, it's not worth my intellect. Let me take your business problem, and I'm going to generalize it so that it would actually fit any business problem. And then I'm going to try solving that problem because that's worth my time. Your problem's too simple. Let's generalize it so that it'll work for everybody and build a framework. If you're building frameworks, you're doing something wrong. And I know in most companies, that's what the good developers do. The good developers make frameworks so that everyone can actually use the framework. But this really isn't what's going to be going on. Now, what we're going to be talking about today, we're going to go through 3 examples. The first example is going to be brownfield. How many of you have worked on a brownfield system before? Ugh. That's not very fun, is it? Maybe you end up reading Michael Feather's book, Working with Legacy Code. Does anyone here know what the definition of legacy code is? It's any code that is more than 24 hours old. We're also going to talk about how do we stop over-engineering in greenfield projects. And what's interesting for me is it's actually easier to not over-engineer when working in brownfield than working with greenfield. Greenfield is actually really, really easy to over-engineer. Brownfield, you tend not to over-engineer as much. And the last example that we're going to talk about is dealing with process managers, or orchestrations, or beeples, or there's lots of different names for the same pattern. How many of you have brought biz talk on a project? Why'd the project fail? And this is exactly what happens every time. That and, well, you know, they've got their salespeople that come in and go, once we bring this in, you don't even need developers anymore. The business people will just draw flow charts and this will fix all of your problems. And this is typical. When we start looking at software, we need to remember that very often there are many, many, many edge cases. But quite often those edge cases are very rare. They don't come up very often. In fact, if you start looking, and we're going to talk more about this, they follow a Pareto distribution. And this is a very common distribution that we find in things coming from nature. But what we really need to remember is that your system is part of a larger overall system. Your software does not live in isolation. Your software exists as part of a business process. You do not need to solve every problem inside of your software. And people always come to me and they go, well, but my software, it needs to solve everything. How many of you have had a bug in your software? So the company went bankrupt that day, right? Or was there some kind of risk management on top of your software that prevented the company from going bankrupt from any bug inside of your software? How many of you have had something happen like you printed an invoice and it came out wrong? And then maybe someone on the business side reviewed it before sending it out and went, hey, this is actually wrong. This is the business process doing risk management on top of your software. This happens in almost every company. To be fair, the companies where this doesn't happen tend not to be around very long. Your software is one piece of the puzzle, but there's other pieces. And what we're going to see today is that very often the best thing that you can do is to actually say, you know what, business side, you deal with this problem. It is not a technical problem, it is a business risk. Very often this is the absolute best thing that we can do. And the reason for this comes down to economics. Due to the economics of the situation, it's oftentimes best for us to not solve a problem. Let's try something really quick. How many of you went to university for computer science? How many of you remember big O notation? Algorithmic complexities. How many of you remember theta? Wow, like 2 hands. So when we're in university, we are taught to think about the worst case for things, correct? We're taught what is the maximum amount of time that this algorithm can run in. But oftentimes when we actually start building systems, this isn't really what we care about. What we tend to care about when building systems is, what is the average time of this algorithm running? I used to, in interviews with students who are coming out, let's say, a master's degree in computer science, I used to ask them, which is better, a red-black tree or a splay tree? And without fail, they would say, the red-black tree is better. Why? Because a red-black tree, to do a search on it, is big O of log n. The big O of splay tree is n. You could end up with a splay tree that goes right. And you could end up searching for the very last node in it, and it could be n. The way a splay tree works, though, is when you search it, it does a rotate of nodes as opposed to doing a walk left and a walk right. The result of this is every time you search a node, it becomes n over 2 in terms of depth closer to the root. So the real question here is, what kind of data are we searching? Is this uniform searches or non-uniform searches? If it's non-uniform searches, all the things that you tend to be searching go up to the root of the tree. It's a classic case of amortization. And very often, in an average case, a splay tree can actually beat a red-black tree, even though it has a much bigger big O. This is the typical kind of problem that we start running into. And our educational system, they teach us that we must solve all the problems in software. They teach us we need to always focus on the worst case. This isn't how business views software. They have a very, very different view about how software works. We are also told, when we deal with risk, that we should always be preventative of risk. We should prevent risk from happening inside of our computer systems. We should prevent bugs from occurring. We should always prevent bad situations from occurring. What's interesting is that business people don't look at risk this way. If you go to a business person, they don't try to prevent risks from happening. They respond to risk. How many have seen a business guy have something bad go on in the business and get together 2 or 3 people and go, oh shit, we've never seen this before, what should we do? And they have a quick 5-minute meeting and they make a decision about what they should actually do in this scenario. And there's a reason why they are taught to be responsive to risk. How many of you think you can enumerate all of the possible risks for your business? I want you to sit down with a pen and paper and enumerate everything that can possibly go wrong in your business. This includes Martians attacking. This includes your director having gone out and spent all of the money on cocaine. This includes anything that can possibly happen in the business. The problem, if you try to prevent all of these things, you're going to sit there writing on this piece of paper for the next 10 years. You can't possibly enumerate all the things that can go wrong. And this is why business people are responsive to risk, not preventative. So let's go through and try an example. Let's talk about brownfield. Everyone likes to say that brownfield systems are awful. And working in legacy code, it's just so, it's a big mess. But very often going through and trying to improve brownfield software is actually easier to not over-engineer than dealing with greenfield. And there's a reason for this. When you're dealing with brownfield software, you have a huge advantage. You have data. You already have users using the software. You have information about what actually they do. You're lacking this in greenfield. So our strategies to stop over-engineering are different between brownfield and greenfield software. In brownfield software, we should take a data-centric approach. Now, how many of you have worked in brownfield? So the biggest problem that we tend to run into in brownfield is meetings. And as you start working in brownfield, people go, we need more meetings. How many of you have worked with a senior junior before? A senior junior has senior title but junior skills. They like to have meetings. Meetings and more meetings and more meetings. But we're not going to do that. Instead, we're going to take a data-centric approach. And when we talk about savings here, we are not talking about, I'm going to reduce your project budget by 10%. We're going to be talking more along the lines of, I want to reduce your project budget by 90%. The thing you had planned a 9-month project on, I want to finish it in 3 weeks. And you can do this on most systems. And I've seen example after example of this. And the way that we do this is we don't focus on building the entire system. For most systems, we don't need to build everything. And I know this sounds crazy. So we're working on an invoice system. And as we're working on the invoice system, I don't know if anyone's ever worked with invoices. Invoices are complex. They're actually very complicated. Think about all the different ways of writing out an invoice. Now imagine that you're dealing with multiple countries, different VAT. Very quickly, you end up in very, very complicated rules around how you write invoices. And what ends up happening when you have lots and lots of complicated rules? Meetings. So we're sitting with the domain experts for somewhere between 1 and 2 weeks, and they're still explaining how invoicing works. It was a really, really complicated process. And finally, what we did is we actually went to them and said, stop. Stop telling us how complicated the invoicing system is. And we took a different approach. Instead of having them explain to us how this invoicing system needs to work, we went and we grabbed all of the invoices from the previous year. So now we have all the invoices that this system did last year. And I went through, and instead of talking about all of the complications associated with invoices, I asked them a different question. What is my single happy path? And how do I know I am still on my happy path? Let's not talk about all the things that can go wrong. How do I know I am still inside of it? And then we went and we implemented the one happy path. And we tried running all of last year's data through it. And you know what we found? 60 to 70% of the invoices went down the happy path. 1 day's worth of work took 60 to 70% of the previous year's work. 1 day. So then what we did is we said, okay, for all the ones we weren't able to process, what's similar about them? And we found there was one edge condition. And that second edge condition, it was about another 10 or 15% of the invoices. That was 2 days. And then we looked at the data and we went, well, what else is in here? What else is similar? And we found another one, and that was another 6%. 3 days. And we iterated over this for less than 2 weeks. And you know where we got to? More than 99% of the invoices were being processed. And then we stopped. All of the complications were in the 1% that we weren't processing. We were doing 99%. What we found very quickly was that it followed a Pareto distribution. If you go measure your software and how often given use cases actually get used, you will find that they follow a Pareto distribution. Once we got to the point where we had 99% being processed, we stopped. And we said, you know what? Let a human do this. We're not going to build it into the software. I have already automated away 99% of your work. To be fair, at the end of the day, we still need a human here, right? I mean, there needs to be a human who's actually looking at the invoices to make sure they look reasonable. Why not give them one invoice out of 100 and tell them to do it manually? I know it sounds crazy. We can use humans as services. And those business experts who are trying to explain all these really complicated rules to me, no, just keep it in your head and you do it. We're not going to build it into the software. But they had expected this system that we were working with, they were expecting us to take 9 months on this. 2 weeks later, we were 99% of the way done, we declared success and walked away. And this is common. This is what people are talking about when they say stop over-engineering. What's going to end up happening, that last 1% that contains 80% of the complicated logic, just don't do it. Walk away. To be fair, you have probably already hit the law of diminishing returns. So that first use case we did, that was very profitable for us, correct? 1 day's worth of work and we automated 70% of the invoices that were happening. That's good. Think about how much value we delivered there. How much value are we delivering later when we're now inside of that last 1% and we spend 4 days modeling something and we realize that this happens once a year? So we just spent 4 days to automate away 5 minutes of his work. Where's my break-even point? How far in the future until I actually break even on this stuff? What we do is we take the big wins early. After a couple weeks, everything should come back to a cost-benefit analysis. And we no longer just talk about things for the sake of talking about them. We no longer have meetings. If you want a feature put into the software, you need to give me a cost-benefit analysis. What you need to tell me is, how often is this failure occurring in production? What is the cost per failure? And how much do you want me to invest? Now, it could be we're having this failure once a day. It takes 30 minutes of human time in order to fix each failure. And you want me to invest 1 day of developer time in order to remove this failure from the system. Cool. Where's my break-even? And what you will start finding is that most things in software aren't worth building. It's perfectly okay for your software to say, manual intervention required. Humans, you come here and fix this problem. Very often, it's cheaper for you to do that from a business perspective than it is for you to fix the problem. Well, let's look in Ukraine. How much does a developer cost in Ukraine versus how much does a customer service representative cost? So if we're going to add a feature and we're going to take 2 developers and have them work on it for 1 week, so we've got 2 man weeks on this process, how many weeks of customer service representative time could we get? We could get a lot. And how many of these could they manually fix before we start saying we're going to build it into the software? This is the discussion that you need to have. We need to remember that we don't need to solve every problem in software. By default, we shouldn't. By default, raise your hand and go, humans, I am doing 99% of the work. Here's something that you can do. There's absolutely nothing wrong with doing this. And what you'll start finding is all of the really complicated logic normally only applies to 1 or 2% of the work that you need to do. And you can allow the software to not do it. And what you'll find is your model gets much, much simpler. Humans are really good at handling this kind of logic. But then we have greenfield systems. Greenfield systems are really hard to not over-engineer. And the reason they're hard to not over-engineer is because you don't have data. Instead, what you have is a bunch of people coming and telling you what they dream may exist one day. You are in imagination land. How many of you have worked on a greenfield project and added features that nobody ever used? I have actually built an entire system that was never used. We built an entire system, nobody ever used it. We spent over a year working on it, it never got used. Greenfield is really hard to not over-engineer. To be fair, in that case, the best thing we could have done is to not build it. But to be fair, there were many swimming pools installed as part of building that system. It's the Accenture business model. By the way, has anyone ever noticed that anytime there's a massive software failure, you'll hear the word Accenture? So the question with Greenfield is, how do I get enough information in order to actually be able to do things like cost-benefit analysis? And I've come up with a pattern for this. I call it throwing shit at the wall. So when we start throwing shit at the wall, what we're really looking to get is an early agreement. So I'm going to go to the business people and I'm going to say, you know that year-long project you want to do? No, we're not going to do it in a year. We're going to do it in 2 months. Now here's the thing. When we do it in 2 months, we're going to continuously deploy and we're going to release it to production. Now the deal is you have to use it. So instead of taking a year, we're just going to build it in 2 months and put it in production. But you have to start using it at this point. And there are no such things as bugs. Or sorry, features. Features no longer exist after the end of that 2 months. There are only bugs. That big report that you need to run at year end that we never knew about and we never implemented, that's a bug. And you can prioritize my bugs. And that's it. You're not allowed to do anything else. Now, we will be as responsive as we can be. If you have a bug that's affecting you in production, you cannot do your job right now, go prioritize that to the top. We're going to start working on it. We're going to deploy it in a couple hours. But you have to use the software. The reason I want you to have to use the software is because now I'm getting data. And I can start seeing how people are actually using it, as opposed to building to some ideal that we have no idea whether or not this is actually useful or not. And we no longer have this concept of features. Everything is a bug. We didn't implement some major critical functionality. Well, that's a bug. And you're only allowed to prioritize my bugs. Now, I call this throwing shit at the wall, but it's also known as agile. And this is what people should be talking about when they talk about agile. They shouldn't be talking about stand-ups or burn downs. This is agile. This is the real heart of agile. It's not Scrum. It's not about stand-ups. It's about me making agreements with people, building trust, getting real information to make a data-driven decisions from production. This is what Agile really is. And it works really, really well when we start getting into greenfield systems. And now that I have real data, remember, we can come back and do cost-benefit analysis. The same way we were doing in brownfield, because now we have data again. But what we really need to focus on in analysis is not everything that can go wrong. And it's a subtle difference. How do I know I am still on a happy path? We can talk about all the things that can go wrong. But instead, focus on how do I know I am still right? And I understand this is a very subtle difference between these two ideas. And the place where we see this the most is process managers, orchestrations, beeples, workflows, whatever you want to call a pattern. And we see people trying to build out workflows that handle all of the error cases. And then you go and look at them in production and you find out that many of these error cases never happen. Let's imagine that we were automating the workflow of building a computer inside of Dell. And we're doing an automated system that takes a picture of the computer as it comes out of the machine that puts the motherboard inside of it. What if there's a dead cat on top of it? Would it make a difference if it were a squirrel? Hopefully it's not these two. They're very cute. But we don't talk about all the things that can possibly go wrong. Instead, we focus on how do I know I'm still in my happy path? When I go to take a picture of this, I should be looking to see that this thing still looks correct. Not trying to enumerate all the things that can possibly go wrong. And this is probably the single biggest thing that we do with over-engineering. We try to enumerate all of the failure cases as opposed to focusing on how do I know if I'm still on my happy path. And there's absolutely nothing wrong with me looking, am I still on my happy path at this point? If I am in my happy path, I continue. If I'm no longer in my happy path, I raise my hand and say, humans, you come deal with this. If you are automating away 99% of your business's work, you have probably already won. At the end of the day, the whole reason your business has a computer system is to make the humans more efficient, correct? If you're automating away 99% of their work, you've already won. Take that 1% of work and hand it over to humans. The trick is, make that 1% that you give to them the really complicated stuff. And you'll see this again and again and again. The really complicated stuff that your software deals with is probably only 1% of the overall work that your software does. Give it to a human. This is especially true when we start talking about long terms over software history. What's interesting is that really complicated stuff, that tends to be the stuff that changes the most. And you spend most of your time updating the software about that 1% of stuff that's really complicated. Just don't implement it. You don't need to implement everything in software. Again, we need to come back and do cost-benefit analysis on everything. You should not just be adding features to software. I want to know, with the investment of adding this feature, 2 days of developer time, where do I break even? Where's my break-even point on this? How many failures do we have on this thing in production? By default, give it to a human. Let a human do it. I know this sounds crazy. We're using humans as domain models. There's nothing wrong with this. Actually, I was over in America, and I was talking with some guys who wanted to build a startup. And what their startup they wanted to do is they wanted to do accounting for nonprofits. Now, accounting for nonprofits is horrifically complex. Because I can donate money to a nonprofit and I can earmark what that money can be spent on. So now think about the other side of this accounting-wise, where you need to match up everything. And what their idea was they're going to build this and automate it. So it basically connects to your bank account, and as things are coming in, it automatically just does all the accounting for you. And they started getting into all these complex rules about accounting. And I told the guy, I said, no, this isn't how it's going to work. This is not a year-long project to build a startup. Instead, we're going to make this a 2-month project. And he went, how can you possibly get all this logic in? This matching logic is really complicated. And I told him, I'm not. You are the domain model. And built out a little screen where he could actually enter in what the matching was. And every morning, because he was a tax accountant, he would come in and he would start doing the matchings. We had no logic for doing this. Our domain model was the domain expert. And then we got more customers coming in, and oddly, they thought our matching algorithm was really, really good. And literally, he would just come in every day. And then I started getting busier, and I went, hey, you know what? Maybe we should hire another domain model. So then there were 2 domain models working. And once I started looking at hiring a third, we came back and we said, okay, now we got data. Which simple rule can we put in that will take away 50% of your work as humans? Okay, let's add that one rule automatically. And this is how we worked. In order to reduce initial investment at the beginning, our domain model was a human. To be fair, if we had actually sat down at the beginning and we said, what are the most important rules to put in the software? It would have been 2 weeks worth of meetings. Instead, we came through 6 months later and said, let's add 1 rule. It took away 50% of the human's work. To be fair, that system is still running today. And they only have about 10 rules implemented in the domain model. The rest goes off to humans. To be fair, they need the humans there anyway, because the humans actually need to audit and check that the thing is doing it correctly. Let the humans take all the edge cases. Humans are very good at this. Don't implement them in the software. Especially at the beginning. Now, I've said something for a while. Every developer needs to go hire a developer to build something for them. Until you've done that, you do not understand the economics of software development. And when you hire this other developer, I want you to pay them in cash, 1 node at a time, so that you feel even more what's going on here. And it might be you want to have a new blog, so you go and hire a developer to build you a blog. And they're a Java developer. Who here is Java developers? So they come back to you and they go, okay, a blog. Well, we're going to use Spring, Hibernate. We definitely use Spring dependency injection. We want to use Tomcat. And you're going, it's a blog. I want fucking WordPress. You cannot really understand the economics of software development until you are the person paying the developer. Every developer needs to go hire a developer to make them a better developer. And very quickly you will start understanding the value of things. So I used to have another interview question I used to ask people. I tell them, so I've got a file, and it's got some CSV data in it. And basically what I want to do is I want to get out the 5th column in the CSV, and I want to come up with an average of the numbers. How would we do this? See, the whole point of what I'm trying to do here is leave it an open-ended question. So like some interesting questions that should be asked back would be like, well, how often are you doing this? Are you doing this every day? Or do you just need to do it once? If you just need to do it once, I think I know a good way of doing this. It's called Excel. How big is the file? Is this like a multi-gigabyte file? But that's not what happens. What happens is developers over-engineer everything. And without fail in this interview, what everyone will say is, so first I'm going to open the file stream, then I'm going to iterate through the rows, but then I start making it complicated. For instance, I mentioned to them, by the way, in the strings, there can also be quotes inside the strings when you go to parse it, so you can't just do an array split. You actually need to fully support CSV. But the right answer in most cases for this kind of problem is use Excel. Or, I've had a couple people come up with and write a little bash script for this. That's totally acceptable too. But without fail, developers will come into this problem and they will over-engineer it. And they will talk about how they will build a custom computer system for this. In order to really understand the economics of software, you need to go off and pay a developer out of your own pocket. Once you've done that, you will understand the value statement going back and forth. Now to summarize, you need to remember that your system is part of a larger system. Your system is not the end. There is a larger business system around your system. And it's perfectly okay for you to punt things off to the business process. You do not need to solve every problem in software. It's okay to let a business process deal with things. What you basically do is go, this is not my technical problem, this is your business risk. And you'll see this over and over and over again. You can get a lot of benefit by punting things over to the business process as opposed to dealing with them in your software. Everything should have a cost-benefit analysis attached to it. You should not be making decisions without having done a cost-benefit analysis. If you're making decisions without a cost-benefit analysis, you're probably wasting money. And what's interesting is when you start doing cost-benefit analysis, you'll start realizing that something like 70 to 80% of the work you're doing doesn't pass a cost-benefit analysis. You are wasting time. It would actually be cheaper to continue doing it manually. And it's literally 70 to 80% of your system doesn't make it past a cost-benefit analysis. And I've had lots of people bring up questions on this one. What about legal requirements? Well, hell, legal requirements are legal requirements, but that's no different than any other rule that we have in the software. We need to be able to detect if we are in the scenario. Am I still on my happy path? If not, push it over. And I actually wrote a blog post up on this the other day with legal requirements, and we actually took the worst, most Byzantine system I know of, the United States tax code, as an example. To be fair, if you actually go look at everyone's returns, even though there's 3 million words of law about US taxes, there's about 8 rules that cover something like 70% of the returns. Go implement those 8 and identify every situation that it's outside of what you know how to do. Throw those over to the humans. Let the humans do those. And push forward, and maybe you can start seeing, oh, well, here's another major rule, here's another major rule, and we just picked up another 20%. By default, you check, am I on my happy path? Yes or no? If I am, continue, else, human. If you can't figure out how to do a cost-benefit analysis, stop and go figure out how to do a cost-benefit analysis. If you're in Greenfield and you're going, well, we can't do cost-benefit because we're in imagination land, stop. Figure out how do I actually get data at this point in order to be able to do a cost-benefit analysis. Don't just put features into software. And again, the way we do this is we focus on our happy path first, and we, in analysis, try to figure out how do I know I have left my happy path. We don't talk about all the things that may go wrong, because there could be thousands. We talk about, how do I know I am still right? And this is a very different question. We don't enumerate all the things that can go wrong. We talk about, how do I know that I am still right? As I said for the example, imagine the motherboard with a dead cat on it. You take a picture of the motherboard to see that it looks correct. You don't talk about everything that can possibly go wrong. And I know this is a very subtle difference, but it makes a huge difference when you start talking about analysis. And of course, the last thing is, deliver value. When you're going through building software, that software, it has a purpose. There's some reason the business is paying you to build it. Focus on the value that you're actually delivering. To be fair, once you actually are doing a cost-benefit analysis, it makes you focus on value. The value that the software is actually bringing. Because in most cases, software is either there to make money or to save money. Although you'll find one odd one, which is software is actually there as a risk mitigation strategy. But normally it's to make money or save money. Understand, when I add this use case, how does that actually affect whether I'm making money or saving money? Do a cost-benefit analysis on it. Where is your break-even for the time that you're going to spend on the software? All of these things, they will really focus you on not over-engineering things. Now, I want to thank everybody for coming out. If people have questions, I will be around, walking around throughout the next 2 days. Feel free to come grab me. Remember, tonight there is a party. If people want, feel free to go jump in the pool. This is not meant to be a very formal event. And I hope everyone has a good time. Thanks.